Hey everybody, in this video I am going to finish up the three problems that we were not able to get through with regard to chapter 6. So this is on the week 7 class handout. Okay, so there were three questions that we were not able to get through because again there's just so much stuff. So that's what the purpose of this video is. I'm going to use PowerPoint to do this, so I shouldn't have to do any writing, which is a good thing. So just showing off my animation prowess. And you have to promise me you will not judge the coloring that I did. I had to use the mouse in order to color in the area, so I didn't have my iPad to do, a quality job of coloring. So don't judge me. Anyway, so this problem asks us to suppose the lifetimes of laptop computers produced by one company are normally distributed. I hope you know what that means. You have to get excited when we see that phrase, so hopefully you're excited. If not, pause the video and go get excited. But anyway, normally distributed, I get to use my chart, Z-score formula, all sorts of things. Now, what usually follows is the mean and standard deviation, and there it is. Mean is 4.6 years, standard deviation is 1.1 years. Part A asks us to find the proportion, specifically what proportion of the company's laptops last longer than 4.6 years. So first of all, we have this question, what proportion? That's a very odd thing to ask. We haven't seen that yet. What do you mean, what proportion? This is a very fancy way of saying what's the probability. And the reason I know this is because proportions are fractions, decimals, and percentages, and so are probabilities. I can express a probability as a fraction, decimal, or a percentage. So no big deal. What proportion, what probability. So just cross out the word proportion and write probability. No big deal. The other thing I need to consider is what does it mean to last longer? Well, last longer means I want to be more than 4.6, means greater than. So this is an area to the right question that we are being asked to figure out. So see how I'm figuring that out based on what the wording says. Last longer means we want more, so that's area to the right. So what really this question is asking mathematically is the probability that x is greater than 4.6. X here is the lifetime number of years. Okay, well, we can't go to the normal distribution table with this because it's not in terms of z, so we need to figure out what our z-score is. So we take 4.6, which is our x, and we subtract the mean, which also happens to be 4.6, and we divide by the standard deviation of 1.1. And what you should notice is you get a z-score of 0. Okay, no big deal. Well, that's kind of nice. It's obvious. Okay, if it's 0, that means we're smack dab in the middle. We're right in the middle of that normal distribution. So that should be 50%. Should be at exactly 1/2. So let's just make sure we're understanding this. There's my picture. There's my beautiful coloring job. There it is. Half of the normal curve is shaded in. So if you draw the picture, this supports what intuition is saying. Now, if you're still skeptical, we can also pull up and look up the value of z on the table. And so 0.00 lands us on 0.5000, 50%, 0.5, half. Okay, there it is. So part A is finished. This was a relatively easy one, I hope. This has been on an old final. We had a lot of people mess it up. Don't ask me why. Actually, you can ask me why. They didn't draw the picture, okay, to really try to understand this. So sometimes it happens. Numerator becomes 0. Now, part B is a bit of an interesting one. Part B is asking us how long. Okay, that's not a probability question. It's how long. What do we mean by how long? Well, how long means how many years. That's what we're talking about in this question. How long would it need to last? This is not asking me about probability. It's actually asking me for time. So this is actually a section 6.4 question. You remember me saying section 6.4 is a bit strange. We have to use the x equals d sigma plus mu. That's formula number 21, because I'm not being asked to find a z-score and a probability. I want to know how long, how many years. So this question, we actually need to do things a little bit in reverse. I know what mu and sigma are. Those are given, but now we need to figure out what exactly is z. And they give us a clue. They tell us that we want the laptops to be in the top 1% of lifetimes. Okay, so where is top 1%? I hope you all agree top 1% is that itty bitty space there. Okay, I wrote top 1%. I used the mouse to write it. That's not bad. It's probably better than my normal handwriting. Okay, but there it is. If I had the stylus again, life would be easy. So it's a teeny tiny area is the point. All right, so that means the area to the right of that would be 0.0100, but unfortunately your normal table does not read area to the right, so I need to figure out what the area to the left is. Well, if I take 100% and I subtract 1%, we get 99. So to the left should be 0.9900. So what I need to do is I need to go to the normal table, and this time instead of looking up a z-score, I need to look for an area. Section 6.4 plays with our mind. So I need to look for 0.9900 or something gosh darn close. And you'll notice in the bottom right corner of this snippet from the normal chart, I have found 0.9901. It's only off by 1/10,000. That's very good. So I notice here that that gives me the first two digits of 2.3. And then the last digit up there on the top is also a 3. So this z equals 2.33 is as close a z as I'm going to get to give me this top 1%. So now I have all the pieces. So I put in 2.33 for z, 1.1 for the standard deviation, and then 4.6 for the mean. And I compute, and I end up with 7.163 years. So in order for this laptop to be in the top 1%, it's got to last longer than just over 7 years. So this is section 6.4. A bit strange, but it asks us to sort of work things a little bit in reverse. The next question is a bit interesting. It's very simply stated. We have a normal distribution. Yay, we're excited. With mean of 15 and standard deviation of 4. And we want to find the probability that x is less than 7 or x is greater than 14. So the first thing to notice is it says x. So I can't go to the normal chart. I need to convert these to a z-score. Okay, we need to get these guys into z. So hopefully you remember that from the concept check. I need to get z-scores. Okay, so we take 7 here minus 15 divided by 4. That's our mean and standard deviation, or the probability that z is greater than 14 minus 15 divided by 4. We simplify, and we end up with -2 and -0.25. So this one's a bit strange. We have this word or. So what exactly is it asking me to do? I want the area to the left of -2 or the area to the right of -0.25. So I need the picture. Okay, there are my two z-scores. There's Richard's beautiful coloring job. Well, my goodness, this is area in the tails. Now, someone's going to say they are very big tails. And my response is, who cares? Who are we to judge how big the tails are? That's just the way this problem dealt it. Okay, no problem. So what I need to do here is I need to figure out the area of each of the two red zones, and I need to add them. Okay, so this is area in the very cute tails. All right, so we add areas. So we have an area to the left of -2, and an area to the right of -0.25. We talked about area to the right in class. Okay, so hopefully this is okay with you. I looked up the area to the left of -2, very simple, and I chose to look up the opposite z-score of -0.25, which would be +0.25. If you recall, that's one of the ways you can handle an area to the right case. The other option would have been to just look up -0.25 and subtract that from 1. Either way you spin it, the area to the left is 0.0228, and the area to the right of -0.25 is 0.5987. We sum the two, and we get 0.6215 as our solution. Okay, so area left and area right combined, area in the tails. And the last question here tells us about body temperatures of adults are normally distributed. Yay! With mean of 98.6 and a standard deviation of 0.73. And look what we're being asked here. What temperature represents the 96th percentile? So what temperature is implying that we're not looking for a probability, but for a value of x, and in this case, the temperature. So this, again, is a section 6.4 question. So again, here comes formula number 21. X equals z sigma plus mu. So the hard part here is figuring out what exactly is z. So they give us a total. They're talking about the 96th percentile. This should sound very familiar because we talked about percentiles in class, and percentile means area to the left. So let me get my picture. There it is. Okay, and there is 96%. That should make sense. most of the curve should be shaded in. What a lot of people will do is put 0.96 all the way on the left side. That doesn't make sense. If somebody's in the 96th percentile, that means they did better than 96% of the people in the class, in the test, whatever the thing is that we are studying. So most of this curve is shaded in. So we return again to the normal table, and this time I'm looking for an area of 0.9600 as an area, and I need something very close. And what we end up getting close to is 0.9599. What z-score is that? Well, that gives me the first two digits of 1.7 and the last digit of 5. So 1.75 is going to get us something very close to 0.9600. Now, some of you may be wondering, well, why isn't this exact? Well, remember the z-score table has the limitation that it only goes to 2 decimal places. If we had the ability to go more decimal places, we could be a bit more accurate. And so this is where technology comes into play, where we might use the computer to actually tell us what these values are, because it would have the capability to give us a more accurate z-score in this respect. But for Stats 1020, this will do, okay, with our sort of crude estimation. All right, so we plug in our numbers here that we know. We know 1.75 is our z-score. Sigma, they told us, was 0.73, so we multiply those two, and then we add the 98.6 degrees Fahrenheit. And so that should give us 99.8775 degrees Fahrenheit, okay, in this case. Some people might ask, what should we round to? You will follow whatever rounding instructions exist for exams, homework, etc. And if it doesn't, I would go maybe 3 or 4 decimal places. You already know for z-scores to always go to 2. So, all right, I think that finishes up that aspect of Chapter 6 for Week 7. So more to come next week with Chapter 7, which a lot of this stuff will again come back to us. So I think that is it. So thank you so much. We'll see you in class, and please enjoy the fall break. I hope you all get a chance to relax somewhat for those 2 days.